Hello, welcome to our presentation. Let's start with the background. Coffee is a big part of daily life in the United States. About 400 million cups are consumed in every day. Even though the US leads in total coffee consumption, it actually ranks 25 in consumption per person. On average, an American drinks around 3 cups per day. Our study explores how coffee habits change across gender, age, and ethnicity. Our research question is how the coffee consumption habits vary by age, gender, and ethnicity in the US. We aim to analyze difference by age, examine how gender affects caffeine intake, and investigate ethnic differences in daily coffee habits. We gathered our data from public sources such as research reports and government statistics, and we cleaned and organized it to create a useful dataset. And since this is a sample, not the full population, our results also represents the general trends based on this sample. At the top, you can see a few sample entries from our dataset showing coffee consumption per day based on gender, age group, and the ethnicity. Below, we present the key summary statistics. On the left, the box plot shows us the overall split that we can see that most people consume between 1.5 and 3 cups per day, with a median around 2 cups. The right, the histogram gives more detail on how the data is distributed. These are range, width, boundaries, and class limits. On the left side, you can see the frequency polygon. This shows the number of people drinking different amounts of coffee per day. And on the right side, we have the OGIV, which shows the cumulative frequency. Stem and leaf style bar chart. It provides another way to display frequency. Again, we observe that the highest frequencies are in the first and 3 cups per day range. We calculated the skewness value, which came out to 0.085. This is a very small value, suggesting the distribution is also symmetric, even though the frequency graph slightly leans to the right, meaning more people drink 1 or 2 cups than higher amounts.
And these slides, we summarize coffee consumption. The mean, median, and weighted mean are very close, suggesting a balanced distribution, showing some spread but not extreme. The coefficient of variation is 0.50, indicating moderate relative variability. The minimum is 0, meaning some people report no coffee consumption. The median is 2.15 cups per day, and the 75th percentile is 2.9. So most people drink between 1.4 and 2.9 cups daily. The interquartile range is 1.475, and the box plot supports this. The QQ plot shows points close to the line, so the data doesn't strongly violate normality. This makes it suitable for parametric tests like t-test or ANOVA. We simulated 1,000 samples, each of size 30. The sample means form a nearly normal distribution, even if the original data isn't perfectly normal. This supports using parametric methods with large samples. We explain point estimates, confidence intervals for means and proportions, and the margin of error. We also mentioned the T distribution, degrees of freedom, and the chi-square distribution for variance and standard deviation. We estimated a margin of error of plus or minus 0.17 using a sample of 150. Since the population standard deviation is unknown, we use the T distribution. With 149 degrees of freedom, we used the chi-square distribution to build 95% confidence intervals for variance and standard deviation.
In this slide, we performed 2 hypothesis tests. The first one checks if the average coffee consumption is really 2.5 cups per day. Our results show a clear difference. The actual average is lower than that, so we reject the idea that people drink that amount. For the independent samples t-test report, it looks at gender differences. Here, the results show that the difference between men and women is not significant. This means gender does not really impact how much people drink based on our data. When we ANOVA test, we check if different age groups have different coffee habits. The results clearly show that age matters a lot. Older groups tend to drink more coffee compared to younger ones. The second test is one proportion test. It checks if at least half of the participants are heavy coffee drinkers. But we found that only about 23% drink that much, which is much lower than expected. Here we compared men and women against using an independent t-test. And just like before, we found no meaningful difference in how much they drink. The results are not strong enough to say that gender makes a huge difference. We also considered doing a paired t-test, but this method requires before and after data for the same people. Since we don't have that kind of data, we couldn't apply this test. In this part, we looked at the relationship between age and coffee consumption using correlation analysis. The results show a strong positive correlation, meaning that as people get older, their coffee consumption increases. We also confirmed this with a hypothesis test. The results clearly showed that this relationship is real and significant, not just a random pattern in the data. Here we double-checked our correlation with using 3 different methods. The first method, traditional method, compares our results with a critical value, and it shows a significant relationship between. This p-value method, it checks the p-value, which is very small, meaning that the result is statistically significant. The third method is confidence interval method. It uses confidence intervals, and since the interval does not include zero, it confirms a positive correlation. Since all three methods agree, we are very confident that age and coffee consumption are positively linked to our data.
Conducted a linear regression which showed that age significantly predicts coffee intake. The slope of 0.637 indicates that for each increase in age group, coffee consumption rises by about 0.64 cups per day, a statistically significant result for us. And the adjusted R-square was 0.383, meaning age explains around 38 point of variation in consumption, a moderate level. For instance, someone in age groups 3 is predicted to drink 2.22 cups per day with a 90% prediction interval from 0.55 to almost 4 cups. There was other T-squared tests as well. The of fit test revealed that coffee consumption is not evenly distributed, and the test for independence showed a significant association between gender and heavy coffee consumption. Similarly, the homogeneity test confirmed that heavy drinking rates differ between men and women. Normality test supported using a pragmatic methods as the data was approximately normally distributed. We also used ANOVA test. Our one-way ANOVA found significant age group differences, and two-case tests showed adults drink more than younger groups. A two-way ANOVA showed both age and gender significantly affect consumption. Non-parametric methods like critical values test and Spearman correlation further confirmed a strong positive relationship between age and coffee intake. In summary, age plays a major role in coffee habits, gender has a smaller but notable effect, and ethnicity differences are also significant. However, only 22.7 are heavy drinkers, lower than expected. Of course, we must consider limitations such as convenience, sampling, and self-reported data. To conclude our analysis and research, age, gender, and ethnicity significantly influence coffee consumption patterns, with age showing the strongest effect. While the findings are statistically supported, future studies should use more diverse samples and combine qualitative insights for deeper understanding. Thank you for listening to us.